अस्सलामु अलैकुम वरहमतुल्लाहि वबरकातुहू। अल्हम्दुलिल्लाह, अल्लाह का बड़ा एहसान है कि अल्लाह सुब्हानहू व तआला ने हमें कुछ चीज़ें सीखने का मौका अता फरमाया है। तो सबसे पहले मैं आपको ये पूछना चाहूँगी कि हम क्लास इंग्लिश में ले लें या फिर उर्दू में ले लें। आपके लिए जो सहूलत होगी मैं वो फॉलो करूँगी, ठीक है? मुझे बताएं आप।
उर्दू एंड इंग्लिश दो भी बोली मैम।
ओके देन, इंशाल्लाह, ठीक है।
ओके मैम।
So let us start our class. Before starting our class, let us recite this dua so that whatever we learn it for our benefit. We ask Allah that whatever we learn, it benefits us, and also we ask Allah to increase us in our knowledge. So the dua is Allahumma allamni ma yanfa'ni wanfa'ni bima allamtani wa zidni ilma. So, inshallah, we will cover some of the topics of integration. Of course, the integration is a very vast topic and it cannot be covered in 1 to 2 sessions. But I would like to go as far as I can in this class. So, firstly, we'll try to understand what is meant by integration, what is differentiation, I mean the definitions of these things, okay? I'll not go into much depth. Then we'll know what is meant by fundamental theorem of calculus and what are definite and indefinite integrals. Apart from this, apart from this, I would also cover integration by substitution. Okay?
Okay, ma'am.
And we know that integration by substitution can be by any of the function or it can be by trigonometric functions, right? So we'll see these two categories if we can cover in 1 hour, inshallah, or else we'll schedule another class for this, inshallah. Firstly, let us try to understand what is the difference between integration and differentiation, because these two terms are very frequent throughout the calculus part, right? So the integration and differentiation are a part of calculus. Calculus is a subject, it's a very vast subject in mathematics, okay? So the derivative is something, it helps to calculate the slope of any graph. For example, consider this graph. This is a graph, this is a curve, right? So at any point of time, if you want to calculate the slope, how can you do that? It's by differentiation. So what is meant by differentiation? We'll select a random point here, and with that point we'll select another point, and in between these 2 points, what is the difference? What is the I can say the difference, yes. So this would be called as differential of that particular curve. And we do the differentiation only to identify the slopes of any curve. So what is the need of differentiation in our life? Why do we need differentiation? For example, if there is a masjid, okay? Do you see masjid in your daily life every day, I guess, right? There are so many domes on a masjid, right?
Yes.
Dome, you see how they construct the dome, you know, it's in the shape of a concave or convex semicircle, you can take it, right? So the slope of that dome has to be even in all the 4 sides. All around, the slope has to be even, right? So from one side, if the slope is this much, the other side, the slope has to be the same. And this is one of the simple example or one of the simple application of differentiation where we apply it in our real life. So civil engineers apply it very frequently. How about the integration? What is integration? Integration is just a reverse process of differentiation. In differentiation, what we are doing, a big graph, from a big graph, we are extracting one single point, right? So I can say that from a big function, we are coming to a small function. Whereas in integration, what we'll do is we'll do reverse of differentiation, where we'll come from a small function to a big function. What is the a lively application of integration? I can give you with the same dome example, where we have the same masjid dome. Apart from the slope, we need to also consider how much area is being given to that slope, to that dome, right? So the dome cannot be one side it's a little tilted and the other side it's a big one. So I hope you're getting my point. यानी देखिए, अब एक जगह बहुत ज्यादा उसको स्पेस दे दिए और दूसरी जगह उसको कम स्पेस दे दिए, तो ऐसी चीज नहीं होना चाहिए. कभी कभी ये होता है कि दोनों स्ट्रक्चर के स्लोप सेम होते हैं मगर एरिया सेम नहीं होता, राइट? सो एरिया भी हमें सेम रखना होता है बहुत सारे स्ट्रक्चर्स में, तो वहां पे हमें इंटीग्रेशंस भी अप्लाई करने होते हैं. तो ये दोनों चीज है ब्रदर सिस्टर की जैसा, या फिर यू कैन कंसिडर देम एज टू ब्रदर्स. सो यू कैन नॉट डू डिफरेंशिएशन विदाउट without knowing complete integration, and also you cannot do vice versa. So this is just basic understanding of why we need differentiation and integration. Basically we have two types of what we can say, the integrals. What are the two types of integrals we have? The definite and indefinite, right? So these two types of integrals constitute to form an integral calculus. So integral calculus is a very big subject in mathematics which has definite and indefinite integrals. So tell me, what is a definite integral and what is an indefinite integral? Yes. Who can tell me what is a definite and what is an indefinite integral? Okay. In the integration, we see the symbol integral, the big yes symbol, right?
Yes.
The big symbol, yes. Sometimes on the big symbol, we have the ranges from here to here, yes. Integrate from A to B. When we have the ranges from A to B, it means that it is a definite integral. We exactly know that from where to where we need to integrate it. You got it right?
Yes, ma'am. Yes,
see here, we have this integral. So when we write A to B, what is this? It is a definite integral. When we don't have A and B, what is this? It's an indefinite. Indefinite means we don't know where to stop and we don't know where to end. Okay?
Okay.
Okay, ma'am.
So we'll move a little forward. Okay. We'll go to integration by substitution because your teacher has asked me to cover this topic. I think you haven't covered this topic, so we'll go with this, inshallah. So before starting integration by substitution, you need to know two basic things. Two basic theorems. I hope you know it, but yet I would like to review it. First is the chain rule. The second is a substitution rule. What is meant by a chain rule? I can say, okay, Nahma is my friend. Sorry to say, did I pronounce your name correctly? Is Nagma or it's Najma?
Nagma.
Nagma. Okay. So Nagma, let us consider that you are my friend. And Masrat is your friend. Then I can talk to Masrat. Masrat can also be my friend. How? In terms of a chain of friendship, right? So
Yes.
how the friends become? They come. Okay, she's your friend. Okay, she's like this. The relationships form in the form of chains. Likewise, the friendships form in the form of chain. So this is a very vague, very broad example of a chain, but here it's a little different. What is meant by a chain rule? We know that, you know what is meant by a function? Function means it has some variations, it has some variables. I can say, okay, if I say f of x, this is a function, right? So
Yes.
I can say
Yes.
x plus 1. This is a function. What is the variable here?
X.
Excellent.
Yes.
This is the variable. What is the constant here?
1. 1.
The constant. Very good. And now I say f of g of x. Okay. So what does this mean? This g of x is a sub-function of this big function. I can say the actual function. Okay. One is a sub-function. Function inside a function. Okay. If this is the case, you need to understand that we have an original function. Inside that we have another function. Okay. I can give you an example. Sine of x cube plus 1. Now tell me, what is the main function here?
Sine. Sine.
Okay. Sine is the main function, or I can say the actual function. What is the sub-function here?
X cube.
X cube plus 1, right? This
Plus
whole
1.
term.
Yes.
This whole term is a sub-function. So there are some properties. There is some theorem of integration which is saying that whenever you are going to integrate a function which has some sub-function inside it, then what happens? Okay, let us carefully understand this. Whenever there is a function inside a function, when we apply the differentiation on it, we do differentiation to that function and also the sub-function. Okay? This is one of the chain rule of differential functions. And if you want to write it in terms of dy over dx, y I am considering as f, the big f, the big of f of u of x. Okay? So how can I write it? df over du and du over dx. Okay? Is this fine?
Yes, ma'am.
Uh, just so what we have is differentiation. Capital F of, or I can say u of x is better, okay? Because we'll do the u of x, okay? Tell me, how can we write this? Differentiation of f of u of x is f dash of u of x, then u dash of x, right? What this is? This is a chain rule.
Yes.
Okay? If I consider this f of u of x as y, this term as y, then I can write dy over dx. Simply, I can write like this, df over dy with respect to y, sorry, with respect to u, not y, okay, with respect to u, and then du over dx. So do not confuse. If you are able to understand this thing, then it's fine. Okay, the lower one, do not worry much about it. Okay, so we know that integration is reverse of differentiation, right?
Yes.
If I apply different integral on this differential part, what will happen? Tell me. What will be there? This integral and this differentiation goes. Okay? It becomes f of u of x and u dash of x equals integral of f of u du. Or I can say this u is equals to u of x. U of x is the smaller function, this sub function. Okay? Okay, I will not bore you much by explaining more about this theorems. We'll just go to the problems. I hope you can catch up very quickly, inshallah. So just let me go with the first problem of integration by substitution. We have a question which is saying 9 sine power 8x cos x dx. Okay, now tell me what you understand. Firstly, this is a constant, right? We'll take it out.
Yes.
And then we have some function here and we have other function here. Okay, but we cannot go directly by integration to this two functions. You cannot do integration by parts. Can you do it?
No.
If you want to do integration by parts, it doesn't have to be here, right? If this power is not there, you can at least think about it of integration by parts. If it was 9 sine x cos x dx, you would have considered it as integration by parts because one is original function and one is the differential form of this, right? So at least we'll get some solution if we don't have the power. But in this case, we cannot do it. But remember this theorem, which we say it as our substitution rule. What is that theorem? F of u of x and u dash of x. Whenever we see like this thing, integral of f of u of x and u dash of x dx, then that will be changed in the form of integral of f of u du, where u is equal to u of x. Okay? Do you feel this line, this question is in the form of this theorem? Do you feel it?
Yes, ma'am.
Yes. So we have f of x, f of u of x, and then we have some f dash of x. So we can consider some part of this function as u. Okay? Some part of the function of this as u, and let us take this in this f of u form. So tell me, what can I take as u? Shall I take sin x or cos x?
Sin x.
Sin.
Sin x as u. Tell me why. Because it has the big power. Okay?
Okay.
If you take u
Yes,
as cos x, then u dash would be
ma'am. Minus sin x.
minus sin x, right? But we don't
Yes.
have here sin x. We have sin power 8x, which is very complicated thing, right? So it's better to take sin power 8x as u. Actually, sin x as u. So what is my u here?
Sin x.
U is sin x. U dash is cos
Cos
x.
x.
Okay. So how can I write? 9 is constant anyhow. Can I write u power 8?
Yes.
Okay.
Yes.
When u is sin x, u is cos x.
Cos x.
Cos x dx. You should not forget this dx beside this. So here we are trying to integrate with respect to u. Then we need to keep this integral in the form of du. Okay, right? So how can I go with the form of du? Tell me. I can write du equals to cos x dx, right? In the place of cos
Yes.
x, I write du. Now tell me this integral.
U power 8 plus 1 by 8 plus 1 means 9.
Right?
Yes.
Plus c.
Yes.
Okay. So we have this, which is u power 9 plus c. What is u?
Sin
U
x.
is sin x.
Tell me what is,
Sin.
why we'll write c here for integration. If you answer my question, why we'll write c in integration, then you will get a chocolate from my side.
मैम सी इसलिए लिखते हैं क्योंकि इसकी बहुत मेजरेबल प्लेस है वो।
किस लिए लिखते हैं? मैं आपको बताऊंगी. ओके,
उसकी मेजर्स जो ना पॉइंट्स में रहते हैं इसलिए उसको सी में लिखते हैं.
मैं आपको और अच्छे से एग्जाम्पल बताऊंगी अभी.
ओके मैम.
Square plus 4. Okay, I have another thing, x square plus 25. ये दो फंक्शंस डिफरेंट है.
नो स्क्वायर में आ सकते हैं.
No. Are these functions different? Do they differ by anything? Okay, don't take something big. X minus 1 equals to 0. ये एक लाइन है. X plus 1 equals to 0. ये भी एक लाइन है. ये दो लाइन सेम है.
नो.
कैसे रहेगी ये लाइन ग्राफ में? बताएं मुझे क्वाड्रेटिक में. इसका बनेगा x इक्वल टू -1. x इक्वल टू -1 इधर आएगा, राइट?
Yes.
यस.
x इक्वल्स
Plus one.
-1. +1 ये वाला किधर आएगा? दिस वन
Right side.
प्लस राइट साइड.
टू 1. तो ये दोनों डिफरेंट है, सेम है? डिफरेंट है, सेम है? These are different. Of course they are parallel, but they are different. They are not the same. Yes?
Yes, ma'am.
So, when I differentiate this function, इसको f1 ले लें, इसको f2 ले लें. मैं इसका डिफरेंशिएशन कर रही हूँ f1 डैश. क्या बनेगा? x minus 1 का डिफरेंशियल
0 1 माइनस 1.
f2 डैश का डिफरेंशियल क्या बनेगा? 1, राइट?
One.
तो
Yes.
अब देखें, दोनों का मैंने डिफरेंशियल किया तो मुझे 1 ही आया. When I want
Yes.
to go back to the original function, अब मुझे ओरिजिनल फंक्शन को पीछे जाना है. हाउ शुड आई डू इट? आई हैव टू इंटीग्रेट दिस थिंग, राइट? मुझे इंटीग्रल अप्लाई करना है, तभी मैं ओरिजिनल फंक्शन को जा सकती हूँ. जब कभी कोई फंक्शन पे डिफरेंशियल हुआ, उसके ओरिजिनल फंक्शन को आइडेंटिफाई करने के लिए हमें क्या करना होगा? इंटीग्रल अप्लाई करना होगा, राइट? तो अब मैं इस पे इंटीग्रल अप्लाई करूं. इंटीग्रल ऑफ 1 क्या होगा? x.
X.
इंटीग्रल ऑफ 1 x. तो हमें क्या है ओरिजिनल फंक्शन? x एंड x. अरे ये तो दोनों सेम आ गए. बट दिस इज नॉट द केस. दे आर नॉट द सेम. They are different. They are differing by one single constant. And we don't know what is the constant there. That's the reason we keep constant after every integration. Okay, समझ रहे हैं ना आप?
Okay.
When
Yes,
we
ma'am.
go back to the original function, we don't know its original form. There may be some constant which have become zero due to differentiation. That's the reason we have to keep plus c every time. So अब इस केस में c होगा 1, इस केस में c होगा -1. So these functions are differing with one single constant. Likewise, every functions differ with the constant, and that's the reason we have the constant thing in the integration. So you got this. And now we'll go to some other problem. Okay, just wait a minute. I can take this call later. आपको समझ आ रहा है ना मैं जो कुछ भी बोल रही हूँ?
Yes, ma'am.
अल्हम्दुलिल्लाह. हम चलते हैं कोई और क्वेश्चन की तरफ, एंड आई एम एक्सपेक्टिंग आंसर्स फ्रॉम यू वेरी क्विकली. इंटीग्रल ऑफ 3x² and cos x³. ओके, तो ये कैसा है बताएं मुझे. इसमें u of x क्या है, या फिर f of u of x क्या है, और u dash of x क्या है.
E of x cos x है, f of x 3x square.
3x square.
f of u of x जो है वो cos x है.
Yes.
ओके,
Yes.
एंड
Yes.
u dash of x जो है वो क्या है 3x², राइट.
3x square. Yes.
नाउ हम इसे कैसे कर सकते हैं. जब कभी हमें इंटीग्रल ऑफ f of u of x and u dash of x dx दिखाई दे तो हम क्या करेंगे. इंटीग्रल ऑफ f of u du, where we will replace u equal to something, right. u हम किसको
Yes.
लेंगे, u of x को लेंगे, राइट. किसे लेंगे हम, u of x को u ले
U
लेंगे.
of x.
तो हमारे केस में u क्या होगा,
Cos x.
Cos x square.
तो अच्छा ठीक है, अगर मैं u cos x ले लूं तो u क्या होगा,
Minus sin x dx.
है हमारे पास ये बाजू.
No.
So you cannot take this one. What you have to take,
Yes.
whatever the integral is there, whatever the
X power 3.
form you have to pay attention on those two functions. So you can be excused, right.
Yes.
So d would be x² dx, isn't it?
Yes, ma'am.
Okay. Integral of cos u 3x and dx की जगह हम क्या लेंगे, d, isn't it?
Yes.
ये 3x² है. ओके, आई माइट हैव मिस्ड स्क्वायर. दिस इज 3x². ओके, सो cos u का इंटीग्रल क्या होगा मालूम है हमें.
Yes,
Yes.
ma'am. Sin x. Sin u.
Sin x.
sin u plus
Yes.
c, एंड u की जगह हम क्या रखेंगे, sin x.
X cube.
X cube.
है हमारा प्रॉब्लम का सॉल्यूशन. एंड नाउ यू आर गोइंग टू टेल मी दिस थिंग. आपके पास बुक एंड पेन है.
Yes, ma'am.
Yes, ma'am.
बैठिए आप. बस मुझे 1 ही मिनट में इसका आंसर चाहिए, 1 ही मिनट में. जल्दी से करें आप. हो गया?
यस मैम।
क्या है आंसर बताएं?
माइनस कॉस ई पावर एक्स प्लस सी।
और नगमा आपका?
Same ma'am. Minus cos e power x plus c.
Excellent job. And now we'll go to a definite integral example where we have 0 to 1 as the limit. So 1 over 3 is a constant here. And the function is sine of x cube plus 1 and 3x square dx. Okay? So अब मुझे without f of u of x ऐसे लिखे बगैर हम लोग जल्दी करेंगे within a minute. 1 over 3 is a constant. You have to follow me very quickly. Okay? So
Okay.
I keep sine u du. Is this right? But I am missing something. This one. तो ये तो समझ आया ना आपको? मैंने u इसको लिया. u will do this. Right?
यस
Follow कर रहा है ना? तो अब जो
यस मैम।
हमारे पास लिमिट्स है 0 to 1, those are the limits of x. Yeah. सुनाई दे रही ना मेरी आवाज?
यस मैम।
Okay. What was our question? That was 1 over 3 integral of 0 to 1 sine of
एक्स पावर
1.
क्यूब प्लस 1 3x square।
this was our question. We took u, this is du, right? So
यस
we are trying to solve this problem by changing this integral from with respect to dx to with respect to du. Okay? पहले x से हम करने चाह रहे थे, अभी हम u से कर रहे हैं. So the limits here we have are of x. They are not of u. So you need to convert these limits, or I can say the ranges, in terms of u. What is u? पहला
प्लस एक्स क्यूब।
क्या है? It's 0, right? पहला वाला क्या है? 0. So u becomes 1 plus 0. It's 1. Second range of x is 1. So u becomes 1 plus 1 cube, which is 2, isn't it?
Yes.
So only here you have to be very careful when you are integrating definite integrals using the substitution rule. You have to be very careful with the ranges. You have to convert the ranges too. If you are fail, then if you fail to change the limits, then you will do the problem in a wrong way. Okay? So
Okay,
1 over 3. Now our new limits are 1 to 2. Sine u du. Tell me the answer.
1 by 3 minus
माइनस कॉस
1
u यस u is 1 plus
1 to 2, isn't it? So these are the limits of cos. You will write it 1 over 3 cos 2 minus cos 1. What is the value of cos 1? You can convert it by using your calculator. Okay? So do not worry about this, or you can just write the answer in this way. This is also the correct. We'll go to the next one. You're noting down the problems,
यस मैम।
or at least you can take the screenshots. Okay? If I'm going
Yes, ma'am.
fast. Next. There is something. If I write, where is my pen? F of ax. No. Let me write something else. This is 3x. What is the differential of this thing?
3.
Right?
Yes.
Okay. If it is f of ax, what is the differential of this thing?
A.
A.
A. And if there is some sub-function inside this, like it may become, if it is an x square, it becomes 2x, right? So I can write
Yes.
f dash of ax, right? This becomes f dash of ax with a constant that comes outside. We have the same rule in integration. What is that? If it is integral of f of ax, then what will be the integral form, 1 over a integral of f of ax.
F of.
Okay?
Yes, ma'am.
Or I can say after integration, this f becomes, I'll tell you two things. Please remember, when I am writing small f, it means this is not the original function. This is a derivated function. When I am writing capital F, what does this mean? This is the original function. Okay? Now tell me, x square, 2x. Which one is the original and which one is the derived one?
Original is x power square.
Original is x square. Okay. And derived is, you are clear, right?
Yes.
Clear? So this is the way we write the original and derived functions using f and capital F. So you understood that whenever we are integrating a function with some constant inside, then that constant come in the form of a denominator. वो नीचे आ जाएगा. Derivative में बाजू आएगा in terms of multiplication. Integration में नीचे आ जाएगा. Okay? You are getting my point, right?
Yes,
Yes.
ma'am.
हम और एक अच्छा सा इंटीग्रल करते हैं. इंटीग्रल ऑफ रूट ऑफ 2x plus 1 dx. ओके, अब बोले हम क्या करें इसको.
पावर लगा सकते हैं. रूट हटाना है.
रूट हटाना है.
We can remove root.
रिमूव. हाउ?
1 by 2. 2x plus 1 whole power 1 by 2. But
ऐसे करूं मैं? You mean this? अच्छा, ओके.
no,
What
ma'am,
you are
power
saying?
में.
ओके. अच्छा, इसको रूट हटाकर मैं ऐसे लिखूं कह रही हैं आप?
Yes, ma'am. 2x
Okay.
plus 1 1 by 2.
इसके बाद क्या करें?
Integrate no, ma'am. X power 1 by 2.
अगर मैं इसको डायरेक्ट इंटीग्रेट कर दूं तो मैं कर नहीं पाऊंगी, बिकॉज आई हैव सम कांस्टेंट इनसाइड दैट. इफ इट वाज जस्ट लाइक दिस, देन आई कैन डू इट. दिस इज ऑफ कोर्स रूट 2 व्हिच इज कांस्टेंट. I can integrate to x power 1 over 2 using x power n formula, right?
Yes.
But this
Yes.
is not just 2x, it has plus 1. So try to use the knowledge that I have given you about integration by substitution of u. What can we do?
U is 2x. Du is 1.
Du would be 2,
2.
right? 2 dx. 2x का डेरिवेटिव क्या होगा? 2. We write dx beside that. You got it? समझ आया क्या? हम
Yes.
u अगर सिर्फ 2x लेंगे तो बाकी का है ना, इसको कैसे लिखेंगे? u plus 1 लिखेंगे. अगेन फिर इसका इंटीग्रल आप नहीं कर सकेंगे ना. u plus 1 होल पावर 1 over 2 होगा ये. तो उसको ऐसे नहीं लिख सकते आप. u plus 1 1 over 2 plus 1 then 1 over 2 plus 1. You cannot write like this. This becomes wrong. Okay, so you need to take the whole term as u. Okay, I have collected some of the very different examples for you ताकि आप लोगों को है ना मैं सारे टाइप्स ऑफ प्रॉब्लम्स कवर कर सकूं। ठीक है, तो जब कभी भी आपको ऐसा आएगा तो टेक द होल टर्म एज यू। नाउ देखिए कितना सिंपल हो जाएगा प्रॉब्लम, रूट यू डी यू, बट समथिंग इज मिसिंग। क्या 2 नहीं है ना यहाँ पर, तो व्हाट कैन
Yes,
आई डू,
ma'am.
दिस इज dx, dx की जगह में मैं क्या रख सकती हूँ, du over 2, राइट?
Yes.
कैन आई,
Yes.
समझ रहे हैं नगमा?
No, ma'am.
नो, ओके, नो प्रॉब्लम, आई विल एक्सप्लेन यू अगेन। तो हमारे पास है क्या, u हमने क्या लिया है 2x plus 1, दिस बिकम्स u, du क्या है बोले, du would become 2, इसका तो डिफरेंशिएशन 1 होगा ना,
Yes.
फिर हम dx लिख देंगे बाजू। तो अब dx इज इक्वल्स टू, ये dx इक्वल्स टू du ओवर 2 लिख सकती हूँ क्या मैं? सुन रहे हैं आप?
Yes, ma'am.
लिख सकते हैं राइट, dx इक्वल्स दिस du ओवर 2, 2 को मैं इधर लेकर आ रही हूँ, कैन आई, I can, right?
Yes.
So
Yes.
it becomes root u du over 2. Done? 1 over 2 is anyhow constant. Root 2 का इंटीग्रल क्या होगा बताएं मुझे।
Root u का
1 over
2
2
by
plus
3x root u
1 sorry, ये u नहीं होगा, 1
2 by
over
3x
2 plus 1, yes, it becomes 1, ये क्या होगा 1 over 2 multiplied by, ये नीचे वाला टर्म क्या बनेगा 3 over 2, ये ऊपर आएगा तो 2 over 3 होगा, राइट? ये 2 over 3
Yes.
बनेगा, ऊपर आएगा तो बाकी का क्या बचा है हमें, हमारे पास u power 3 over 2, isn't it? नगमा अब
Yes.
आपको समझ आया?
Yes, ma'am.
ये है हमारा आंसर, where we need to substitute the value of u again. What is u? This
u is 2x plus
2x plus 1.
हाँ, तो हम ये सब्स्टिट्यूट कर देंगे तो फिर हो जाएगा, खत्म। ओके, डन।
1. Okay.
Okay, ma'am.
Take it forward, take your pens and take your book. I'm writing a question for you. चलिए आप करिए। Go and open the door. हो गया? Tell me the answer. तो ये तो बताएं कि कैसे स्टार्ट किया। Are you there?
Yes, ma'am.
Yes, ma'am.
कुछ आया?
No, ma'am.
Okay, no problem. No problem at all. Okay. So what I do, whenever you see some x and beside there's something, so what you need to take that thing as u. तो इस केस में मैं u ले लूंगी 3x minus 2, तो du क्या होगा बताएं?
D is 3.
3 dx.
Now solve this. अब इसे solve करें.
Yes, ma'am. Ma'am, 1 by 3 e power 3x minus 2 plus c.
1 by 3.
E power 3x minus 2 plus c.
Excellent.
Yes.
मसरत आपको आया?
Yes, ma'am.
Good.
1 by 3 e power u plus c.
Yes. E power u would be 3x minus 2.
Minus 1. Yes.
Now we'll go to the another problem, and then I'm going to give you some homework. Okay, inshallah. So
Okay, ma'am.
our question now is 0 to 3 pi over 2. Okay, and cos of u, and sorry, this is not u, this is 3x dx. Tell me, what should I take u? U should be
3x.
very good. U would be
3d. 3 into d.
dx.
Yes.
Okay. So now I need to change something else. What is that?
Limits u 3 pi
Exactly.
by 3.
I have to change the limits with respect to u. Okay.
Yes.
So
Yes, ma'am.
what will be the new limits? Now u equals 3 of 0. Now the u is 0, right? u1.
Yes.
U second limit 3 of x. What is x here?
3.
Pi over 2.
3 pi by
9 pi over 2. Okay. Good.
yes.
Sorry. Here the question has pi over 2. Okay. This is not 3 pi.
Okay.
It's just pi over 2. So this becomes 3 pi over 2. The new limit of u2. Our integral now it becomes 0 to 3 pi over 2 u cos u du over 3. Isn't it? This thing. dx की जगह में du over 3.
Yes, ma'am.
Okay. So 1 over 3 is anyhow constant. Integral of cos u, tell me.
Sin u.
Sin. Yes. Yes.
3 pi by 3.
अब हम ये substitution करेंगे. Okay. We'll substitute this thing here. 1 over 3. Sin 3 pi over 2 कितना होगा? This is minus 1. Okay. And sin 0 क्या होगा? 0.
90. 0.
These are 0 degree. Radians है ये. Okay. Radians को हमें value देना पड़ेगा. This is 1 over 3 is our answer. I'll tell you another. Okay. Before I say something, just tell me how much time you can spend with me. How much time you can spend with me more? Have any other works?
Yes.
Okay. So we'll just end with one question and then we'll reschedule later whenever we get time. Okay.
Okay.
Yeah. So our another question is integral of tan x. Do you know how to do this? Do we have the integral of tan x directly?
No.
We don't have, right?
Yes.
And what other integrals we don't have directly?
Sin x and cos x.
We have it. What we don't have, I'm asking. Integral of secant x we don't have, right?
Next.
And what else?
Cosecant.
Okay. So now we can. Okay. So how we can solve this integral? If you just think very carefully to this thing, you can do it by U substitution. How? Can you convert tan into sine by cos? Can you?
No.
Yes.
No?
No, ma'am.
Can you write tan into sine by cos?
No, ma'am. You can't.
Okay. Just tell me this thing. Okay. Tan is sine by cos. Is this right or not?
Yes, right.
Yes, ma'am.
This is what I am asking. Can I change this integral of tan x into sine x by cos x? Can I? Yes, right?
Yes.
Yes.
So, if you remember, we got some problem where we had sine and cos. In that case, we took some higher power function as u, right? We had sine power 8x
Yes.
cos x.
Yes,
In
ma'am.
that case, we
Yes,
took u equals to sine x. In this case, what will you take as u? We have one function and which is differential of other. And this function again, the other is differential of other, right? So you can take any one as u, but you have to intelligently select u here. How? If you take this u as sine, what happens? Du would be cos x, which is down. We don't need it. We need something which is up. So better go u as cos u. Okay?
Yes, ma'am.
So u would be cos u and du would be
Minus sin u.
sin u d. Right?
Du.
Sin x is in terms of x. So minus du over u. Isn't it?
Yes.
Yes.
This is du and this is u with one extra minus.
Yes.
Integral of 1 over u is?
U power minus 1.
Okay, u power minus 1.
1 by u means log u. Sorry.
Very good.
Log u.
If you do it, u power minus 1 and plus 1 and minus 1 and plus 1, it becomes undefined. Okay? So for anything, 1 over anything is log of. Log of u.
U.
Negative of log of u. Okay, just let me come up again. Okay. And here I have negative of log, what is u? It's cos, right?
Cos. Yes.
u plus c. Sorry, this is not u, this is x. Right? Cos x.
Yes.
Now, here I have minus. Can I write like this? Okay. Whenever we have minus of something, some trigonometric function, we can write it in this way. How? I'll explain you a bit more. Yeah. See here, I am explaining from this point. I can write log of cos x power minus 1. Okay? Can I write like this? You know, log of a power m is equal to m log a. Do you remember? So I can write it in this way, right? This is m log a. So I can write log a power m. Log a power this m minus 1. Minus means minus 1, right?
Yes.
So to this minus 1, how can I write log of 1 over cos power 1? Can I write like this? This
Yes.
minus 1, if when it comes to the bottom, it becomes 1, right? Okay.
Yes, ma'am.
1 over cos means? 1 over cos means? 1 over cos is what?
Cos of
1 over cos. You don't know 1 over cos?
1 over cos secant.
X plus c. Okay. This is end of our class, and inshallah we'll look some trigonometric integrals and trigonometric substitution in the next 1 or 2 classes. Okay, I'll give you some homeworks and note down your homeworks. No, I'll send it through the PPT in the group. Okay, inshallah. Thank you very much for your time. I hope
Okay,
you
ma'am.
understood and we'll learn more, inshallah. Assalamu alaikum.
Yes, ma'am. Waalaikum assalam warahmatullahi wabarakatuh. जी, ma'am.